Hi learners! In today's video, you will learn how to find the surface area of pyramids. Determining the surface area will be demonstrated and explained in details to let you understand the concept easily. Real-life applications are shown, thus making the concept relatable and meaningful. Towards the end of the video, you will also have a quick look at its cross-section. Strategies in analyzing and solving problems related to the topic are demonstrated to let you gain an understanding on how these are done so that you will be able to successfully answer geometry problems similar to these in the future. If your lesson is on solid geometry, particularly on pyramids and their surface area and cross-sections, or if you have an assignment on this topic, or if you're preparing for a test in math, or a test in geometry in particular, or you're someone who is interested in learning math, then this video is for you. As shown in the previous video lesson, the most famous pyramids in real life are the Great Pyramids of Giza, the Pyramids of Egypt, and the Louvre Pyramid in Paris, France. We also have rooftops of buildings and houses, floor signs, radios and cell towers, and camping tents that are built and designed having the shapes of pyramids. As you see here, a pyramid is a 3D object or solid having one base, which is a polygon, like a triangle, a rectangle, or a pentagon, and lateral faces that are triangles that converge to a single point at the top called the apex as shown here. On this video lesson, we will only consider right regular pyramids. A right regular pyramid is a pyramid whose apex is directly above the center of its base, which is a regular polygon. We have a regular polygon when its sides are equal in length, like this square that we have here. For this type of pyramid, the right regular pyramid, the distance from the apex to the center of the base is the height of the pyramid. This line, representing the height, is perpendicular to the base of the pyramid. Since the base has sides that are equal in length, all the lateral triangular faces are congruent. Now, aside from the height of the pyramid, there's another height here, the slant height. This is the distance from the apex to the center of the triangular base. This forms a right angle with the base of the triangular face as shown. This slant height is also the height of the triangular face. On this video lesson, we will limit our discussion on this type of pyramid, the right regular pyramids. Take note that the name of the pyramid is taken from the type of the base it has. If the base is a square, we call the pyramid a square pyramid. If the base is a triangle, we call the pyramid a triangular pyramid. Our objective today is to know how to determine the surface area of right regular pyramids. To be able to grasp fully how to obtain the surface area, let us first find out where the formula in solving for its surface area came from. Let us imagine the right square pyramid here as a box and open it. Opening it will give us this net. What shapes do you see here, learners? You're correct. We have here 4 congruent triangles, the 4 lateral faces of the pyramid, and a square, the base of the pyramid. All in all, we have 5 surfaces, the 4 lateral faces, and 1 square base. Now, the sum of the areas of these 5 surfaces is the total surface area, TSA in short, of the pyramid. Do you agree, learners? Thus, TSA is the surface area of the triangular faces plus the surface area of the base. Let us label the figure with variables for clarity. Let the sides of the base be A, B, C, and D. Take note that for us to be able to solve for the area of a triangle here, we need to know the height of the triangle. Let us draw the height of each triangle and label them as well. Learners, what are these heights in our pyramid again? Okay, so these are the slant heights of our pyramid. Since the triangles are congruent, the slant heights are the same for all the triangular faces. Let us call the slant height S. Look at the formula again for the total surface area, learners. We have two components here, the surface area of the triangular faces and the surface area of the base. Let us start working with the first component, the surface area of the four triangular faces. Remember that the area of a triangle is 1/2 the base times the height of the triangle. Putting all the four triangles into our formula, we get this for the surface area of the four triangular faces. So we have the surface area of the triangular faces is 1/2 A times S plus 1/2 B times S plus 1/2 C times S plus 1/2 D times S, where A is the base of the first triangle, B the base of the second triangle, C the base of the third triangle, and D the base of the fourth triangle. The above equation can be written simply as 1/2 AS plus 1/2 BS plus 1/2 CS plus 1/2 DS. Factoring out 1/2 and S, we have 1/2 S times the quantity A plus B plus C plus D. Look at the figure, learners. What are A, B, C, and D on our figure? You're correct. They are the sides of the base of the pyramid. Now, the sum of these sides is the perimeter P of the base. With the perimeter P, the surface area of the triangular faces becomes 1/2 S times P. For the area of the base, let us use variable B. Thus, its surface area is surface area of the base equals B. Plugging in the expression we got for the surface area of the triangular faces and the surface area of the base, we now have the total surface area of right rectangular pyramid, which is 1/2 S times P plus B, where S is the slant height, P is the perimeter of the base, and B is the area of the base. There you are, learners. I hope you were able to follow. Okay, let us have this sample problem so you will know how to do it. Here is the problem. An engineer is tasked to paint an existing monument having the shape of a right square pyramid with a side of 60 feet and a slant height of 55 feet as shown. Part 1. How much of the exterior will be covered with paint in square feet? Option A, 1,980 square feet. Option B, 3,600 square feet. Option C, 6,600 square feet. Option D, 7,200 square feet. Part 2. The paint is sold in gallon. If a gallon of paint covers 375 square feet, how many gallons of paint will be purchased? Option A, 17 gallons. Option B, 17.6 gallons. Option C, 18 gallons. Option D, 18.6 gallons. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. What is asked in the problem, learners? Okay, here we're asked to find two things. First, we're to determine how much of the pyramid's exterior will be covered with paint. Second, we're asked to find the number of gallons that need to be purchased if a gallon of paint covers 375 square feet. What are given? We're given a figure of the right square pyramid with dimensions. Okay, since there are two questions here, we will start with the first question first. Now, the question on how much of the exterior will be covered with paint is tantamount to finding the surface area of the square pyramid to be painted. Do you agree, learners? So, let us start with the formula for the total surface area of the pyramid. So, we have TSA is equal to surface area of the triangular faces plus the surface area of the base, which is 1/2 S times B plus B. Note that the surface area to be painted is what we are trying to find out here. By the way, can we paint the base of the monument? Okay, no. In that case, we can cancel out the term for the surface area of the base. Can you follow, learners? Thus, we are only left with the first term, which is the surface area of the lateral triangular faces. These, learners, is the exterior of the pyramid that will be covered with paint. Let us then have this part of the formula. Remember that in this formula, P stands for the perimeter of the base, which is the sum of the sides of the base of the pyramid. Since the base is a square, each side has a length of 60 feet. Do you agree, learners? So, perimeter P is 60 feet plus 60 feet plus 60 feet plus another 60 feet. And this gives us 240 feet. Now, plugging in the values into our equation for the surface area, we have 1/2 times 55 feet times 240 feet. Multiplying 55 feet and 240 feet gives us 13,200 square feet. Dividing 13,200 square feet by 2 gives us 6,600 square feet. So what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so it is option C. The exterior of the pyramid that will be painted is 6,600 square feet. That was easy. Okay, we move on to part 2. Part 2 of the word problem is asking us to find the number of gallons of paints to be purchased. To answer the question, we divide 6,600 square feet, the surface area of the pyramid's exterior, by 375 square feet. This gives us 17.6. So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option C. So, the number of gallons of paints to be purchased is 18. Take note that the paint is sold by the gallon. There you are, learners. That was again easy. As promised, we will have a quick look at the pyramid's cross sections. Recall that a cross section of a solid is a 2D surface obtained upon slicing or cutting through the solid or 3D figure. Here, we will only examine the cross-section of right pyramids obtained upon slicing the solids parallel and or perpendicular to their bases. Let us investigate what shape will the cross-section be if the right square pyramid shown here is sliced parallel to its base. Let's go. Okay, so slicing a right square pyramid parallel to its base produces a cross-section similar to its base. Here, the base is a square, so the shape of the cross-section is also a square. The size is different, but it is a square. Did you see that, learners? Now, how about if we slice the pyramid from its apex going down perpendicular to its base, what do you think will be its cross-section? Let's go and find out. Okay, so slicing the pyramid from its apex going down perpendicular to its base produces a triangular cross-section. Let us now have this simple problem. Here's the problem. Below is a right triangular pyramid. What shape will its cross-section be if it will be sliced parallel to its base? Option A, square. Option B, triangle. Option C, rectangle. Option D, pentagon. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. What is asked in the problem, learners? Okay, here we're asked, what shape will the cross-section of the right triangular pyramid be if it is sliced parallel to its base? What are given? The figure of the right triangular pyramid is given. So, what we will do here is to slice the pyramid parallel to its base. Let's go. So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option B. Its cross-section is similar to its base. The cross-section is triangular in shape since the base is a triangle. Okay, there you are. Now, how about slicing the right triangular pyramid from its apex going down perpendicular to its base? What will be the shape of its cross-section? Let's go and find out. Okay, so slicing the same right triangular pyramid from its apex going down perpendicular to its base produces a triangular cross-section. Did you see that, learners? There you are, learners. I hope you acquired lots of learnings in today's video. Let us summarize what we have learned today. We have learned that, first, a pyramid is a 3D object or solid having one base which is a polygon like a triangle, rectangle, pentagon, etc., and lateral faces that are triangles that converge to a single point at the top called the apex. Second, the total surface area, TSA in short, of the pyramid is the total area occupied by the four lateral triangular faces and its base. Third, the formula in solving for the total surface area, TSA, of a right regular pyramid is 1/2 S times P plus B, where S is the slant height, P is the perimeter of the base, and B is the area of the base. Fourth, the unit of measure for the surface area is in square unit of length, like square inches, square feet, square meters, etc. Fifth, the cross-section of a solid or 3D figure is the 2D surface obtained upon slicing or cutting through the solid. The cross-section depends on the orientation of the cutting or slicing made. Sixth, when solving a problem, you must read it and may read it several times when needed to know what you're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. Seventh, when a figure is given, make use of it and modify when needed. It is there to help you analyze and solve the problem. There you are, learners. Hope this video helps. That is for now. If you have any questions, leave a comment below and do not forget to like, subscribe, and share this video to your peers so others will learn too. Bye.